All right, so we're going to finish up 10.5. Okay, this will be the last section that's on the test. Okay, we talked a little bit about this equation yesterday. X plus y equals 3. Okay, the goal of this section is to basically take something that's written as an equation and draw a picture of it. Okay? Every problem on the test from this section, that's what you have to do. Okay, make a picture of that. Okay, we talked about, well, how do you make a picture? Okay, generally we find 3 points. Okay, we try to pick x values that are small. Okay, Mr. Roy mentioned that yesterday. 0 is good, 1 is good, -1. Okay, somewhere around there. Pick some small values. Okay, in this problem, you can pick any 2 numbers that add up to 3. Okay? So if x is 1, y could be 2. 1 plus 2 is 3. If x is 0, y could be 3. Okay, 0 plus 3 is 3. Anything. Any 2 numbers that add up to 3. Okay? When you have an x and you have a y, then you take the 2, you put them together. That's when you get a coordinate. Okay, we mentioned that yesterday too. So if I was going to graph this on a grid, what I'd do is take my graph paper. I would only graph 3 of these. Maybe this one, and that one. Once I have 3 points, then I can connect them with a line. Okay, so that's the basic idea. All right, we talked about what makes something a function. Okay, if none of the first numbers, repeat, that makes it a function. Okay? So if you look at it, we've got a 1, a 0, a 2, a 3, and a 4. Any repeats with those numbers? No? Okay, so if you don't have any repeats, that's called a function. And specifically, we're drawing a linear function. Anybody remember what the word linear means? It's kind of right at the beginning, Savon. It's a line. Okay, we're drawing functions that are straight lines. Okay. Generally, our functions are always going to have 2 letters in them, an x and a y. Sometimes the y will be by itself. Okay, so it'll be like this. Sometimes the y won't be. It might have something like this. Okay, we're going to go over one of these again today. So if it's not by itself, first thing you got to do is take anything that's not a y, put it on the other side so we get y alone. All right, so this idea of standard form. Okay, we're not going to go over standard form in this class. This is a different way to write an equation. Okay, we just want you guys to know that the way we're showing you isn't the only way. Okay? We're going to skip this way though. Okay, but this is called a standard form. All right. So, most of our equations are going to have 2 variables. Okay, and yesterday, Mr. Roy broke all that down for you. Solve the equation for y. Okay, I'm not going to go through all the steps he put up, but that's our goal. Okay, get the y by itself. Then, pick some reasonable values for x. You can pick anything you want, but the easier numbers you pick, the easier it's going to be for you to do the work. So I would suggest 0, 1, -1. Okay? If you're going to pick something bigger, that's okay, but make sure you have graph paper big enough to fit the number you want to pick. So if you pick like 10 for x and you got to triple it, 10 tripled is 30, that might be off your graph. Yeah, Isaiah?
So how are you going to know if the answer is correct on the test?
I'm going to be looking at a picture. So we're going to do that today.
So does it have to be like a diagonal?
Yeah, it might be a line at a diagonal, it might be a straight vertical line, it might be a horizontal line, but I'll know by looking at your picture. Yep. Because everybody could pick different points. But no matter which points you guys pick, if you do it right, you're all going to have the same picture. Okay? All right. So before we graph this one, let's look at something we did very first week of school. And let's say we wanted to get y by itself there. What would you have to do to get y by itself there? Just one thing. Yeah, Savon? Subtract 2. From each side. Okay, and you're done. You got y alone. Okay? So the idea that we're doing in this lesson, it's the same thing. You just have to get y alone. Let's try one that's a step harder. 3y plus 8 equals, let's say, 15. How would you get y by itself here?
Subtract 8 and then divide by 3.
Perfect. Subtract 8. And what's 15 take away 8? 7.
What? Then divide by 3.
And then divide by 3. Okay, so you guys just did it. You got y by itself. Okay. Now we're going to look at an equation that has more than one letter, but it doesn't change how we do it. Let's say we had 3y plus, I'm going to make it very similar to the top one, 8x equals 15. These two equations are almost the same thing. And how you do this one is the same first step, except there's something extra with the 8 you have to subtract. So what would you do first?
Subtract 8x.
Good. Very good. Subtract 8x. Okay, now the only difference here is, can you combine something that has a letter with something that doesn't? No. Before we could. 15 minus 8, you can do that. But you can't do 15 minus 8x, so you just leave it. Now, Mr. Roy gave you a suggestion about where you put the x. Where should this term always be? What we have is okay, but we got to put it somewhere else. Still on the right side, but it should be where? It should be in front of the 15. So how would we put it in front of the 15? Yeah, we just move it. Okay? So we have a negative 8x. What else do we still have? Positive or negative? Positive 15. Okay? So it's exactly the same thing we just did when we didn't have an x. Okay? What was our last step in this equation up above? To get rid of that 3. Divide by what? 3. Well, here, it's the same step. Divide by 3, except we got to do it in every spot. Okay? Every term, we have to divide by 3. And we're done. That's it. So in this case, we get kind of messy numbers. Okay? We can't divide 3 into 8. We can do 3 into 15 though. What's 15 divided by 3? 5. So yeah, we can do that. Okay, so I wanted to kind of compare what we did at the beginning of the year, getting a variable by itself, with what we're doing now. We're still getting a variable by itself. It's just now there's an x and a y, but it's the same basic steps.
Guys, can I just talk a little bit about that too, Mr. Hager?
Yeah.
Let's see this for a second. Can I go back? Let's see here. See what I can find here.
We have an example we're going to do next, Mr. Wright.
Oh, do you have one?
Yeah, we're going to do one right now.
Let's do this. Let's do 3x minus 1. All right? And guys, what's the mistake? I don't want to be bossy pants here. I'm just going to erase this so I have a little more room. Guys, what's the form we want to get it in? Anybody remember from yesterday? What's that form we want to get it in? What do we want to have first?
Y.
Y, by itself, right, with nothing else. Y equals, what should come after that? We're not talking slope yet, but what letter should come next, Joe? No, what letter? This x. Then you're going to have a plus or minus, and then at the end, 80% of the time, you're going to have just a number. So this is the form we're trying to get it in. You always want y on the left-hand side by itself. All right? So now, Tyler, if I had something like this, what's the first thing you want to do to make it look like that?
First of all, you want to make it a negative 3x.
Minus 3x, right? I'm going to subtract 3x. I talked to some people about this today. All right? Where do you want that negative 3x to go? On the other side of the equal sign. Think about it like this. All right? I think of like this, the x in this situation. Most of the times when you have questions like this, it's going to come at the beginning. It's very boring. It's like my parents. All right? Every year for the last 30-something years, whether it be end of July, beginning of August, my parents go to Hampton Beach. Every year. They don't go anywhere different. They go to the same place every year. They'll stay at different places on the beach, but they go to the same place every year. Figure the X in this situation, like Mr. Roy's boring parents. All right? You gotta give them, first of all, you gotta give them their ticket. If it's positive, give them its negative ticket. If it's negative, give it its positive ticket. What I do is, I circle it so I know. Like Tyler told us, it's always gonna go directly after the equal sign. It's very boring. It was a boring life, like Mr. Roy's parents, because they go to the same place every year. So right after the equal sign, who could tell me what's going to come right directly after the equal sign? Isaiah. Negative 3x. And then what's left? Who could tell me by raising their hand what's left? 1. 1. What kind of a 1, Spencer? Positive. There's nothing else with it? It's a positive. We assume it's positive. So I'm all set on this side of the equal sign. Remember, X, boring life, goes to the same place every time. Go ahead, Tyler.
But there's a negative sign on the Y, so
Yep, we're going there now. So what do you want to do?
we want to take the negative sign.
Well, what are we going to do first before we do that?
Put a 1.
Let's bring it down first. All right, and like Tyler just told us, it's a negative Y. Now, last step. What do you want to do, Tyler?
Make it plus.
How do I make that negative Y positive?
Add 1.
No.
But
Divide 1
Divide. We're going to divide. I agree. And I'm going to divide everything
by negative.
by -1. All right? This is why you went through, why did you go through this whole big pain in the butt step? What was the whole purpose for doing that? So the math gods could torment you with their hatred?
yes.
No. Why did you divide by -1? Eli. You need that Y to be positive, right? The whole basis of doing this is to get Y by itself. When I divide a negative by a negative, it gives me that positive that I need. Now, what happens to the rest of it? Wyatt, what happens here, buddy?
You divide negative 3x by negative 1.
And what would you get?
Negative
Positive 3 with the X attached. All right? At the end, Justin, what are you going to get with this and this? Positive 1 and -1. Huh? No, remember, we're not subtracting, we're dividing. Positive divided by a negative. It's going to be 1. What's your sign, Justin? Negative. Right. And guys, guess what? That's all she wrote. You're set. Right? Y's by itself. The biggest thing is, once you get by this step and you're going to move the X around to the other side of the equal sign, once you get to this part, whatever's with Y, divide everything by it. If there's nothing with Y, you're done. So if you had like a 2Y here, divide everything by 2. If I had 1,000Y there, divide everything by 1,000. Divide by whatever's attached to the Y. That's going to give you what you need.
All right, so the only one we'll do that's a review from yesterday, then we'll move on, is this one. Okay, is that good? We got a letter all by itself. So is that already all set for us?
No,
No, why not? I already have the letter alone.
because it's not Y.
Yeah, it's not Y. X is alone. We don't want X alone. We'll talk about some special cases, but not this one.
Nothing like that.
Okay? So, what do we have to do?
Subtract 1.
Yeah,
Subtract.
1.
Yeah, that's a good first step. Subtract 1. Subtract 1. Now, can you subtract a number and a letter?
No.
Nope, so you're just going to have to leave it as x minus 1. Okay? That's a little different because we got y on the right. But we're going to solve it the same way, and then at the end we can fix
Yeah,
it.
what could Mr. Even guys, at the beginning, if you wanted to, what could Mr. Hager have done?
You could have just flipped it around.
You could have swapped, good, Isaiah, could have swapped it, right? Could have done 2y plus 1 equals x. That way the equal sign's at the end, it's like math problems like you've done forever. You could have done it that way, or if you want to do it this way, that's fine too. All right, whatever you prefer.
Right, and what's our last step? How do we get rid of that 2 next to the y?
Divide.
Yep, divide by what?
2.
Where?
Both sides.
Both sides.
Everywhere.
Okay, what's on the right side by itself now?
Y,
Y? What's on the left side?
2x.
Is that x times 2 or x divided by 2?
Divided by
That's x divided by 2. Minus what number?
1 over
Minus a half.
Minus a half. Now, how can we make that? Isaiah said it a second ago. Let's make it look more like the ones we've done. What do we do?
Format, what's on it?
Yeah, just switch what's on the left and the right. Anytime you have an equal sign, you can always do that. So what would go on the right now?
1/2,
That's not 2x.
1/2. Wouldn't it be 1/2?
Yeah, you could write it as 1/2 x. Sure, this is the same thing. If you want to do that, that's actually really good, if you recognize that. And then minus what? Minus 1. Well, we already got the x, so what comes next?
2.
Minus 1/2.
Yeah, it's both. It's a tricky one. Guys, we're not gonna ask you, that's a challenging one, guys. We're not gonna ask you anything that crazy tomorrow.
All right, so now we're going to make our table, okay? So we're going to pick some x's. Then we have our equation, y, and then we'll have our ordered pair.
Guys, what should Mr. Hager, Ryan, what should Mr. Hager pick for numbers for x?
0, 2.
0, 1, 2 is fine. Mr. Hager, do they have to have a negative?
No, that's okay. No, you don't need negative.
Like, Tyler, when we were working this morning, you're like, Mr. Roy, I don't want nothing to do with those freaking negatives. I don't want to be anywhere near them. If you want to do 0, 1, 2, that's perfectly fine. Whatever you feel comfortable with is what you use. Okay? And I know some of you guys, look at, Mr. Hager read my mind. Some of you guys struggle with this stuff, the positives and the negatives. Use a calculator. I'll have calculators available for the test tomorrow. All right? Don't just try to wing it. If you get to this point and you set everything up perfectly, don't make a small mistake with your math to lose credit. Use a calculator. We're going to let you. We're going to use them all year.
All right, so now what do we do with each one of these x values? Let's start with the 0. What do you do with that?
You plug it in for x 1/2 0, and then minus 1/2.
Yep. Good. So you plug in the 0 for x. Now let's do it out. I think we could probably do this one without a calculator. What's half of 0?
0.
0? What's 0 take away a half?
0.5.
So 0 take away a half, it's going to be a negative 1/2. If you're not sure, just 0, take away a half. Calculator gives it to me as a decimal. You could do it that way or as a fraction. So what's my coordinate? X was 0. What was y?
-1.
Yep, some people said negative 0.5, negative a half, same thing. Okay, how do we do the next one?
1/2 times 1
1/2 times 1
minus 1/2.
minus 1/2.
Guys, what's Mr. Hager doing? What's he doing, Joe? How's he getting all this crap, this 1/2, 1 minus half? How's he getting all that?
He's putting in the number.
Yeah, what number though?
1.
What is he plugging in for?
X or
The x, right? He's plugging in for x and he's getting what?
Y.
Y. Whenever you're doing a table like this, you're solving for y. You're plugging in x, you're solving for y. Okay? Every time.
All right, so
Is
on,
that Ryan?
I get it.
okay, on my calculator, the way I have to type in 1/2 is like that. Okay, on yours, you might have a button for a fraction.
ABC.
Okay, so 1/2 times 1, and now I'm going to subtract 1/2. What do I get?
0.
I get 0. So what's my coordinate?
1, 0.
1, 0. Okay, and now let's do one more just to make sure we get a good line.
1/2 times 2
1/2 times 2
minus 1.
minus 1/2. Okay, how do we figure that out? Just use our calculator. Okay. There's 1/2 times 2 minus 1/2. What do I get? Yep, 0.5 or 1/2, same thing. What's my coordinate?
2 and 1/2.
2, 1/2. All right, so now, yep, now we're going to go over how you graph it. Okay. So let's start with 0, 1 half, negative a half. Okay. 0 tells us we go left and right how much?
0.
Yeah, we don't go left and right.
You go up 1 half.
What about the negative 1 half?
Oh, you go down half.
Go down 0.5. Each one of these grid lines is 1.
You should make them 0.5.
Yep, you can change the scale if you need to. For us, I don't think we'll need to. So you don't go left and right, go down 1 half. How about the next point? Can somebody tell me, how do I graph this one?
You go
The right one.
to the right.
To the right one, up and down,
0.
0. Now we're going to get our third point. If our third point is something like this, then we made a mistake. All 3 points should be nice and straight. Okay, let's check it. 2, comma 1 half. How do I graph that one? 2 over which way?
Right.
2 to the right, and then up 1 half. Okay, let's see if it works. Hopefully it works. 2 to the right, up a half. Do those look like they're in a straight line?
Yes.
Yes.
It was on the dot.
Yep. So now once you have your lines, you have your dots, just draw in your line. Just like that. Okay, so on the test, if you need to do something straight, you can use your ID. Whatever you have to make it straight, that's fine.
Hey, Mr. Hager, correct me if I'm wrong, but I don't think there's going to be any fractions on there, right? Like fraction graphing.
Please don't want there to be.
Probably not. Yeah,
That's a tough example, Zach. That's a tough example, guys.
yeah, because it had fractions, but if you get that one, that's good.
Yeah.
That's a tough one.
As long as you know you're solving for y, you're plugging in for x. That's all you gotta do. Get y by itself, pick your numbers for x, that'll give you y, then graph.
All right, so the next thing, I think some of you have already seen a little bit in your MCAS prep class, okay? So sometimes they don't use the letter Y, okay? Remember when we did the mapping diagrams? We had these pictures, and we drew the arrows.
So guys, right now we're on the back side of the notes from yesterday.
Remember when we did these mapping diagrams?
Yeah.
Sometimes we labeled the diagram, we called it F, sometimes we used G, sometimes we used an H, okay? Whatever letter we wanted to name it. Well, we're going to start using that kind of notation again. Okay? And the notation is called F of X notation. Okay? Just like we learned on Tuesday, okay, when we used that notation. So if you're given something like this, F of X equals 3, and I ask you to graph it, all you have to do is understand that F of X is exactly the same thing as having a Y. So most of the time what I do, if I don't like F of X, I just change it to Y. That's it. Okay. How about this one?
So guys, that's one mistake, I'm sorry.
If I had F of X equals 3x minus 8, how could we rewrite that in a way we're more familiar with? We could change that F of X to what?
Oh, don't you just put it y?
Yep. And then what would be the rest of it?
Y equals 3x minus 8.
Exactly.
Hey guys, look right there. Doesn't that look similar to your notes where it says F of X equals, and then it says Y equals? That's what you want to write in. Then you have the little bracket there, and that means same. F of X and Y mean the same thing. All right, so I should see people right now on their guided notes writing that in.
So literally all you have to do is change F of X to Y, and then it looks like something you're more familiar with. Okay, any question on that?
Where it says just change, you put under where it says change.
Yep. Just put it right under there. Just change F of X to Y. That's it. Okay? If you don't mind the F of X, you can leave it. But a lot of people like to see it like this, rather than like it is up above. But they are exactly the same thing. There's no difference. All right, so let's try graphing this one. Okay, so it says F of X equals 3x. Well, you can pick x's. I suggest like 0, 1, 2, simple numbers. But we'll do that in a second. Okay? First thing I'd like to do is rewrite this in a way that looks more familiar. Y equals what? 3x.
Next step now, Ben, what do you think Mr. Hager's, what do we need to do now? What should we be thinking about right now, Ben? Well, we should be asking ourselves, right? Is y by itself?
Yeah.
Okay, so it's in that format that we need, right? So after we get y by itself, Ben, what's our next step? What are we gonna make? Okay, we're gonna graph it. There's a step. Relax, man. You're okay. Before we gotta get some points to graph first, right, Ben?
Yeah.
How do we get those points?
I have no clue.
Okay, that's okay. Guys, what do we need to do in order to get those points? Good. Make the table, right? Perfect, right. Very good. So the first thing is the x. Then what's going to go next, guys? What's Mr. Hager going to write next? Which is? This 3x. After that's going to be what? Will. What's going to be after that? What's in that column?
Y.
Y. Good. Last thing, Eli, is what? Perfect. And those are going to be your what in that column? What are you going to get out of that column? Your coordinates, right? That's where you're going to get your graph. This is an easy peasy, right, guys? Y's by itself. Didn't have to move anything around. Perfect. What do you guys want to use? What do you want to use for let? What do you want to use for numbers? Marcus, what do you got?
0, 1, and 2.
0, 1, 2. You're using the Gushelaw method. So, what's Mr. Hager gonna write now? Somebody tell me by raising their hand. What's he gonna write? Say Vaughn. Never mind. Okay. Do you want him to write never mind?
3.
What do you want to write, Kayla?
3 times 0.
3 times 0. Dan, you in the mood to answer anything or no?
No,
You want or you don't?
I don't want.
Okay. Will you try? What's he gonna
Just
get?
say no.
What's he gonna get for y? Dan.
0.
0. Perfect. And Spencer, the coordinates are what?
0.
0, 0. Awesome. Laura, what's next?
Oh, 3.
3 what? 3 what?
3 parentheses.
3 parentheses 1, which means what?
Times.
And what goes for y, guys?
3.
3. Good. Coordinates are? Coordinates are? 1, 3. Awesome. Victoria, what's next? Oh. Awesome. What are you going to get for y? Joe, what's Mr. Hager going to get for y when he does that? Awesome. And Wyatt, what are the coordinates?
2.
Perfect. Good job, my man. That's it. Done. And then the last step is going to be what, Ben? What you want to do before? Plot it, right? Graph it. Awesome.
Now we found 3 points. Okay, to make a line, you really only need 2. Why do you think we did 3?
Because we're special.
Because you're special? Why else? Why do you think we did 3?
To see if what you're doing is actually correct.
Yeah, just to double check. So if you get 2 points and then you get 1 like that, something's wrong. Either the first 2 points are right and the last one's wrong, but something's not right. If you get all 3 points nice and straight, chances are you did it really right, really good. Okay, how do you graph the point 0, 0?
The center.
Yeah, it's right at the origin. Doesn't move at all. Okay, Tyler, how about the point 1, 3?
Graph it.
How do we graph 1, 3?
Go over on the x. On the graph.
I'm not sure what you mean by over. Which way's over?
Right.
To the right 1, yep.
And up 3.
And then up 3. Okay, so now we've got 2 points. This third point is going to be the one that checks if we got everything right. 2, 6. Okay, who can tell me, how do you graph the point 2, 6, Savon?
You go up 2 and over 6. No, you go over 2 and up 6.
Over which way? Which way's
Over
over?
to the right, up 6.
Got it. So right 2, up 6. Do those points look like they're in a straight line?
Not really. It looks like it's bent a little.
Let's see, right 2? Nope, I think that should be good. Let's draw the line and see.
It's bad. Yeah, but it had fx.
Perfect.
Okay, so there's our line.
I think
Just the way it looks on the dots, yeah.
Same thing, just a little line.
Okay. Any question on that one? So on the test, if you've got a problem to graph and it says f of x equals, you can change it to y.
You have to move again?
Okay, let's try this one and then we'll go to our last type. What's the first thing I should do here? F of x equals negative. Okay, guys, I need everybody back up
Guys,
here.
hold it together. You guys have been great so far.
Let's try to make this look like something we're more comfortable with. Yep.
Change that to f of x to y.
Change f of x to y. Okay.
Equals negative 2x.
Negative 2x plus 1. Okay, what do we have to check for next?
Y by itself.
Y is by itself.
It is by itself, so do we have to move anything? No. So now what can we do? Start doing.
Solve.
Right before we graph it.
Table.
Make a table.
Hey, guys, if you're not sure on those steps, that was the front side of your notes from yesterday.
Okay, let's pick some good values for x.
1, 2, 3.
1, 2, 3.
Y 3.
And I said so.
Deal with it.
All right.
Oh, wow.
So what am I going to put right here? About
Negative 2 times 1 plus 1.
negative 2 times 1 plus 1. Okay. What's negative 2 times 1, Katie? You can do that. Negative 2 times 1. Negative 2, yep. Someone else, what's negative 2 plus 1? Marcus?
Negative 1.
Negative 1. Okay. What's my coordinate? About Matt? 1, negative 1. Is 1 point enough to graph a line?
No.
No. 1 point's not enough to graph a line. You got to have at least 2. And we're even doing a third one just to double check. Okay, let's plug in 2. What's negative 2 times 2? Laura? Negative 4 and then add 1? Good. And again, if you get stuck, you can always use your calculator. 2 negative 3 is the point. Yep. Okay, and last one. We're going to have negative 2 times 3 plus 1. What's negative 2 times 3? How about Will? Negative 6. And then Wyatt plus 1? Yep, good. And Chelsea, what's my coordinate going to be? 3, negative 5. Now we got all the points. What can we finally do that we want to do? We can graph it. Okay?
No one wants to get that.
Yeah, you do.
Guys, just for the sake of time, Mr. Hager's gonna graph it real quick.
Yeah, let me graph it.
I think people feel pretty confident about graphing.
All right, so then we got 2, negative 3. And now the third point, this is your check. If you made a mistake, this should help you find it. 3, negative 5. Okay. Do those look like they're all in a row?
Yes.
Yep. So we're good. Just draw in your line. There we go. Okay, so there's our line.
I have a question. Isn't it supposed to go through the origin?
This one won't because of that plus 1 at the end, but we're going to talk more about that next week. If you have a number at the end, like a plus 1 or minus 1 or anything, it won't. Notice where it does go through, though. Plus 1. Okay? The last problem, it didn't have a plus or a minus, and it did go right through the origin. So that plus or minus affects it. We'll get to that.
Yeah.
Not today.
Right, guys, that were on the special cases from yesterday.
Okay, two special cases. Okay, so everything that we've shown you so far, okay, applies to lines that are at angles. Okay? They could be angled going down. Okay? They could be angled going up. Okay? All kinds of different angles. But vertical and horizontal lines are two special cases. And these are just two cases you have to try to remember. when you have a vertical line, okay, I want you to try to think of what number doesn't change. Like, let's say you had the coordinate 0, 0. Give me a coordinate that's right above 0, 0. 0, 1. Give me the coordinate that's right above 0, 1. These are all in a vertical line. 0, 2. And give me one more. 0, 3. What number do you notice stays the same each time, the x or the y? The x. The x was always 0. So when you have a vertical line, the equation of it is going to look a little different. It's only going to have one letter. Every one we've done so far had two, an x and a y. Vertical lines don't. They only have an x. And an example of a vertical line, x equals 2. Okay? X equals -3. Vertical lines always have x equals a number. Always. Where's the y? We just said there is no y. Not when you have a vertical line. This is a special
Where's
case.
the Y on the graph? It's down, right?
Yep. Yep, so you got to be careful you don't mix it up with the axes. That is a little tricky. Okay, let's think about a horizontal line.
Mr. Hager, can I just?
Yeah.
Just so people.
I'm going to do the same thing with the points again for horizontal line.
Here's my coordinate grid. Which one's the x? Up and down or across?
Side to side.
Across. Side to side is x, y. Just so you know, that's your x-axis. All right?
Okay, so Mr. Wright makes a good point. You've got to be careful because the x-axis is horizontal, but we're dealing with vertical lines here. That's x
Guys, the
equals.
way I think of this is, graph it, if x equals 2, graph it on the x-axis, draw your line opposite the axis. Because think of it, if I had x equals 3, put my point at 3, if I drew my line across, you wouldn't see it. Would make no sense to graph it that way. Find the coordinate on that axis, draw your line opposite of the axis.
All right, so now let's look at the horizontal line. Okay. What's a point that's to the right of 0, 0? Nope, 0, 1's above it.
1, 0.
What's another point that's to the right of that?
2, 0.
2, 0.
2, 3.
What's one more point to the right of that?
3, 0.
What number do you notice is always staying the same? Y. Every time, the y was always 0. It stayed the same. So when you have a horizontal line, all the points are going to have the same y value. We just showed it. So horizontal lines are y equals a number. Here's two examples. Y equals 4, y equals -8. So if I wanted to put a horizontal line at 5, all I have to do is write y equals 5. If I want a vertical line at 7, all I have to do is write x equals 7. Okay? These are special cases, so a little different than everything else we did. Okay, so we've talked about functions. What's a function again?
When you have none of the same numbers.
That x has no repeating.
Yeah.
Yep, the x.
Which is also called you have the blank and the range.
Domain.
Domain, right? That's the first coordinate. When the first coordinate does not repeat, that's a function.
Okay, so we have.
Tyler? Correct.
Yep, so we know what a function is. Okay, that's when none of your values in the domain repeat. What about linear? Linear means what?
Constant.
No. Linear means line. Okay, look at the first 4 letters of the word, linear. Okay, so we're talking about relations where the first value doesn't repeat, that form straight lines. And now this word constant. Constant means it's horizontal. So a constant linear function means we have a horizontal line, none of the first values repeat. Okay? Kind of breaking down what that means. Constant linear function.
I mean, guys, for those ones, you don't really need to make a table. I mean, as long as you know where it is, put your point, draw your line opposite your axis. All right, so guys, for y equals 3, y equals 3, Tyler, you think you can graph that?
Yes.
Go ahead.
Mess this up. Yep, just use, yeah, you can actually, let me.
Okay. How do I do this? Just draw it down?
To the right.
Point, yeah.
Oh, okay. And like,
Yep, if you want to fix, you want to make it bigger,
oh,
just drag that to the left. There you go. That's it.
Again, he found 3 on the y-axis, made his point, and drew the line opposite of the axis. Don't draw on the y-axis, you won't see it.
Okay, any question on that? How he got, so look, if you're not sure, always look back, y equals is always a horizontal, and he put it right at 3. Okay, let's try, how about this one? First decide, is it going to be horizontal, or is it going to be vertical? It's y equals a number.
same one as the last one.
What kind is that, horizontal or vertical?
I think Ben has it.
Yep, so then what kind of line do you have when y equals a number? What is it, a horizontal or a vertical? Horizontal, okay? If you're not sure, go back and check. Horizontal, y equals. Okay, and then where's that line going to go?
Down 4.
Yeah, down 4. That's it. So there's your line, y equals -4.
Wow.
See how much easier it is to graph the special cases?
Yeah, I like it.
Okay, how about x equals, what kind of line is that? Vertical. Where is it going to be? Yeah, up and down, but where up and down?
Left 2.
Left 2, exactly. Okay. Just so you don't get confused, I'll label that's the axis. What's next to it is the line. Now if we look at that, is that the graph of a function? Let's just put some points on there. These are all points. We have as many points as we want.
Yeah, it's not a function.
Why not? How can you tell looking at it that it's not a function? We talked about this. Joe?
Because both sides are equal.
Well, look at the points. Look at the arrangement of the points. What's happening?
Oh, because the x is going through 2 lines. It crosses through 2 lines.
It crosses through 2 lines. I'm not sure. What do you
They're sharing this.
think about the points? For example, if you had something like this versus something like
Sure.
this,
No,
what's the difference?
every x coordinate for that line is going to be what, Joe? Every x coordinate for that, -2. You can have -2 every time, right? What's the rule for it to be a function? They have to be different. Are they different? Not a function. Was that, I think that's where you were trying to go there, but I'm not sure. Maybe, maybe not. Just say yeah, Mr. Roy, so I feel better. Okay, good.
All right, so there's our vertical line, and that is not a function. How about this
Again, they
one?
repeat.
Look at the points on this line. Do they line up vertically?
No.
No. So would this be a function?
Yes.
Yes, it would be. Okay, that would be a function. Okay. How about that one?
Guys, just by even before Mr. Hager graphs that, is that going to be a function, yes or no?
No.
No, how come? Tell me why by raising a hand.
The x,
Go ahead, Kayla.
the x is going to be always 3.
It's going to be 3 every time. Justin, what's the rule for it to be a function? wrote that again, bud. For it to be a function, what's the rule?
Oh, not repeat.
Can't repeat, right? What's happening here? What's repeating? The x, which is 3, right? 3 is gonna repeat every time. You can have 3, 0, 3, -2, 3, -8, doesn't matter. It's gonna repeat, right?
Okay, so there's our line, vertical line at x equals 3. So we just said that vertical lines are not what? They're not functions. Right? So we can use a vertical line if we have a picture and we want to test if it's a function. Okay? And this is called the vertical line test. Okay? If you have a picture of something, okay, I give you a picture already drawn, and I say, is it a function? Take a vertical line and draw it anywhere you want in the picture.
Draw it multiple times.
Yep, you can draw it multiple
You have to
times.
skip past it,
Exactly. If it hits a graph more than once,
then it's not a function.
then it's not a function.
If it passes once,
Yep, if it only hits it once, then it is. Okay, let's look at this one.
That's on your notes, guys. That's the one all the way to the left on your notes.
yes.
Okay, let me draw a vertical line. Wherever I put that vertical line, is it ever going to hit the red one more than once?
No, it only passes it once, so it's a function.
Yes, perfect.
No, yes.
No, it's an answer.
So that is a function. Okay, how about that one?
No.
No,
Why not?
because it hits twice.
Not if I put it right there.
Doesn't matter. Doesn't matter, it'll still go through. You're rude.
Right. If you can put it anywhere and it hits that thing more than once,
It's not a
it's not a function. So a circle is not a function. Okay, and last one.
Guys, when I pass it out, don't worry about it right yet.
Yes.
Okay,
Yes, sir.
It's a function.
Yeah, that's it.
okay, look at that. Is that a function?
Yes.
Is that vertical line ever going to hit the red thing more than once?
No, but that looks absolutely
Nope.
super cool.
Now, what if I did a horizontal line? Would it hit that red one more than once?
Don't worry about it now. Just gotta leave it out, though. You're gonna need it.
Yes, it would, and that would.
Yeah, if we did a horizontal line, but what's the name of this test? It's not the horizontal line test. It's the vertical line test. So is this a function or not? Okay.
Guys, hold it, guys. We're not done yet. Hold it together.
Isaiah, how about that last one?
Of course.
What do you think?
No.
So the idea is if you draw a vertical line,
Wait, no, no, it does not touch the knee twice.
so what is that? What was I just going to explain to you? What does that mean if it doesn't hit it twice?
It's a function.
Exactly. Okay, no matter where you put this line, it only hits it once. That's a function. Okay, any question on that? All right, so what we're going to do, Mr. Roy, I think you have a review worksheet.
This is review questions for the board.
Okay, so we're going to do some review questions, and then the homework tonight will be
Worksheet.
a review worksheet. Okay, and your example for your test tomorrow will be
Two, I think you said two.
example 2A,
2A from Tuesday.
2A from Tuesday.
Which one does that look like? Does these all say the same exact date? Literally.
That's going to be from, if it's Tuesday, that's November
Third.
3rd.
They all say
Wait, no,
November
that's the
5th.
fourth.
Tuesday is the 4th.
Hey, guys, that's Monday.
Okay, so make sure you get that example on your review
Again, don't
sheet.
worry so much about that right now. I want you guys to focus on practicing. Right?
Okay, our test tomorrow will cover sections 10.1, 10.2, 10.3, and 10.5.